Now that you've learned all about ionic compounds and covalent compounds, a way that we often draw covalent compounds is using Lewis dot diagrams or Lewis diagrams. So we're going to learn how to do that today. And so the first thing you need to be able to do is you need to be able to look at the periodic table and figure out how many valence electrons. So let's take a look at fluorine. So the first thing, of course, you need to do is locate fluorine on the periodic table. Then you need to be able to figure out how many valence electrons fluorine has. Now, of course, if you remember from earlier in the school year when we numbered these A groups, you'll remember that then fluorine has 7 valence electrons. We don't do the transition metals, just those A groups, numbering those 1 through 8, and those are the numbers of valence electrons. So to draw the Lewis diagram or Lewis dot diagram for fluorine, we would draw fluorine's symbol. Then what you want to do is you want to imagine a box around fluorine, like this. And then you're going to draw electrons on each side of the box to show the valence electrons for fluorine. So fluorine has 7 valence electrons. I'm going to put 2 over there, 3, 4, 5, 6, 7. Now keep in mind that these electrons are constantly moving, so while I've drawn them in that spot or those spots around fluorine, they can move, and we're going to see later on that they're not going to stay stationary in that spot. Let's draw another one. Let's draw carbon. So first, locate carbon on the periodic table. How many valence electrons does it have? So let's go ahead and write down carbon, the symbol for carbon. Imagine a box around carbon, and now you're going to draw in electrons for each of those. So carbon, of course, has 4, so 1, 2, 3, 4. Just trying to draw them nice and neat so that you can clearly see where they're located, because it's easy to kind of lose track of them. All right, let's do one more. Let's do aluminum. So again, think about aluminum. Write down its symbol, Al. How many valence electrons are we talking about? And imagine that box around aluminum and go ahead and draw that in. So that's how you draw a Lewis diagram for an element. It just shows a dot for every valence electron. Now, as we're taking a look at this, oftentimes what happens is our atoms can bond together. And so let's take a look. Let's draw some Lewis diagrams for some simple molecules. So suppose that we have H2. The molecule H2. How would we draw that? Well, if you remember back from your periodic table, hydrogen has 1 valence electron. We've got 2 hydrogens here, each with 1 valence electron. And so when we have H2 in a covalent bond, what's going to happen is each of these hydrogens is going to share their electrons together. We can draw that right here, as you can see. And so these shared electrons, shared by both atoms, these electrons are then going to move around each of these atoms. And so both hydrogen atoms are going to think that they have 2 valence electrons. Of course, that's all hydrogen wants. It is our exception to wanting 8 valence electrons. So another way that we can show that is just with a line instead of the 2 dots. So you can see that pretty clearly. Let's try another one that may be a little bit more challenging, and that is, let's try O2. We didn't draw the diagram for O2 earlier, or O. So let's take a look and see if we can do O2. Once again, what you're going to do is think about O2. How many valence electrons are we talking about? Well, each O has 6, so we would draw the symbol for O. Imagine a box around it. 1, 2, 3, 4, 5, 6. Then another O, since it's O2. 1, 2, 3, 4, 5, 6. And so what's going to happen then is they're going to share electrons here. Now what we've got to be able to do is look at this oxygen atom and figure out if it has an octet. So let's take a look at this one right here. At this point, does that oxygen on the left have an octet? 1, 2, 3, 4, 5, 6, 7. It does not. Let's take a look at the other oxygen on the other side. Does it have an octet? So let's take a look at that one. 1, 2, 3, 4, 5. Oh, sorry. I circled one that should not have been there. There you go. 1, 2, 3, 4, 5, 6, 7. It also doesn't have an octet. So what will these two oxygens do? Well, if you're thinking all they need is one more, they could share one right here. And so now we've made a double bond. And so the way we would draw that is like this. Now those electrons that are not involved in the double bonds, they're going to make what we call lone pairs. So we'd have these two up here. Then we're going to have these two. I'm going to put those down here because remember, electrons are negative. They want to be as far away from each other as possible. And 2 here, and 2 here. So now we have a double bond, and this is what our O2 molecule would look like. At this time, let's try one more, and you're going to pause the video and see if you can do this on your own. Let's try S2. So as I said, this is a good time to pause the video and see if you can draw this one. So if you came up with something that looks like that, you are correct. So how do we draw some of the more complicated covalent compounds that we've been talking about in class? Well, there's a few steps to that. And the first thing that you would need to do, so let's do water. We've talked about water a lot in class as a covalent molecule. And so the first thing we would need to do is figure out how many valence electrons we're talking about. So if we have water, we need to determine the total number of valence electrons. So for the hydrogen of course is our exception. It only has 1 valence electron. So, and there's 2 hydrogens here. So 1 times 2 is 2. We know that oxygen has 6. So if we add that together, and there's only 1 oxygen, so that's a total of 8 valence electrons. And so that is the first step, to count those valence electrons. The second step is to determine the central atom. So if we're talking about water again, the central atom for water and for any compound is typically the one you have the least of. Well, that's going to be oxygen. So you would put oxygen in the center. And then surrounding oxygen, you would draw the surrounding atoms, which obviously in this case are going to have to be these hydrogens right here. Nature tends towards symmetry, so if we put a hydrogen on the right, you're going to want to put a hydrogen on the left. Now remember that we have 8 valence electrons that we're working with. And so now what we would do is draw in bonds between the central atom and the surrounding atom. So let's draw a bond here. Now keep in mind that that bond represents 1 electron from hydrogen being shared with an oxygen electron. And the same thing on the other side. One oxygen electron being shared with a hydrogen electron. So that's really 4 electrons. Every bond is 2 electrons. So let me go ahead and do a little bit of math here, because if I subtract those 4 electrons I just put in, I've only got 4 more to valence electrons to spread around. And so we're going to need to keep that in mind. So the next thing, and we've actually already done this, was draw bonds between the central atom and the surroundings. And then our last 2 steps are to put the remaining electrons on the surrounding atoms as lone pairs. So as you recall, we had hydrogen bonded to oxygen, bonded to hydrogen, and we had 4 more valence electrons to put around. And so we will put those on the surrounding atoms. Oh dear, our surrounding atoms are hydrogen. Hydrogen only needs 2 valence electrons, and you can see both of our hydrogens have that. Now let's take a look at our oxygen. Does our oxygen have 8 valence electrons? So if we take a look at the oxygen here, it thinks it has 2, 4, so it needs 4 more. So we're going to put these 4 valence electrons on this oxygen. 1, 2, 3, 4. These electrons here, again, as we've already mentioned, these are going to be called lone pairs. And I did make mention here for you in step 5 that you give every atom 8 electrons except for hydrogen. Hydrogen only gets 2. It is the exception to our octet rule. So let's follow those same steps and see if we can do another Lewis diagram. Let's do, here's a pretty common one that we do, SO3. So remember the first step, we've got to figure our total valence electrons. So let's locate S and O on the periodic table. Obviously, S and O, they're in the same group. So they have 6 valence electrons. So for sulfur, we have 6 valence electrons. For oxygen, we're going to have 3 times 6, or 18 valence electrons. So if we total those up, that's going to be a total of 24 valence electrons. Our second step, let's determine our central atom. The central atom, again, is typically the one that we have the least of. Often it comes first. And so I'm going to determine sulfur as our central atom. And now we're going to put our surrounding atoms around. And in this case, I'm going to suggest that oxygen is our surrounding atoms. Again, nature tends towards symmetry. So I put an O on the right, I put an O on the left, I put an O above, and now I'm out of O, so I can't have one underneath. Now I'm going to draw bonds in between them. Remember, each bond represents 2 electrons. So that's 6 valence electrons that I've just put in here for those bonds. Now we need to make sure that each atom, we spread these remaining valence electrons around so that each atom gets an octet. So we have 18 to put around. So let's start here with these surrounding atoms. So that's 2, 4, 6. All right. So now I have 12 more. 2, 4, 6. So I have 6 more. 2, 4, 6. And now we check to see that each atom has an octet. So let's take a look at this oxygen here. The first oxygen on the left. As this oxygen looks around itself, how many electrons does it think it has? 2, 4, 6, 8. So it's good. Now let's take a look at this next one. How many electrons does it think it has? 2, 4, 6, 8. So it's good. And this next one, 2, 4, 6, 8. So it's good. Now let's take a look at sulfur in the middle. How many electrons does sulfur think it has? 2, 4, 6. So it is not good. So now what you can do, then the last step, step 5, which we haven't done yet, is we're going to take one of these lone pairs of electrons and we're now going to turn it into a double bond. Remember, it's still counting for 2 electrons, so we're still with our 6 valence electrons from over here putting around, but now sulfur has an octet. And so that's how we draw these Lewis structures 4 molecules.